Hi guys, Mr. Pistone here. I'm going to get started again on 5.1 just to remind you about how we got started here. We agreed that this object was speeding up because as you look at the change in position, it is increasing each time. So during each time interval, the position change increases, therefore it must be speeding up. So what we did was we calculated the velocity. We did change in position over change in time. So we were kind of making this sort of a symbol over here to help us. We did this minus that. So 0.1 minus 0 is 0.1. So that's my change in position, numerator, divided by change in time. So how much was the change in time? 0.1 minus 0. Your delta t is over there. So 0.1 divided by 0.1 equals 1 centimeter per second. Okay, do the same thing again. So 0.5 minus 0.1, 0.5 minus 0.1 is 0.4, and that is your delta position, or change in position, divided by change in time. 0.2 minus 0.1 equals 4. Okay, look, my velocity went up, so I am accelerating. And you could put this here at the beginning, start at 0 velocity. 1.1 minus 0.5, change in position is 0.6 over your change in time, and again your change in time is 0.1. Okay, we notice that our change in time is not changing at all. Actually, it's consistent. Right? And that's because, as we read up here, the spark time was set to 10 hertz, okay, which is 0.1 seconds. So that's never going to change. Okay, this is always increasing by 0.1. The only thing that's changing is your position, or your delta position. Right? And this will equal 6, and again our velocity went up. Alright, so that's what you want to do. You go ahead and do that. And then you're setting up your velocity graph. So I believe the largest velocity that you get up to is 23. Yeah, I'm just going to put a question mark by that, so check that on your own, but I'm pretty sure that's the largest velocity. So when you go over here to your VT graph, you need to decide what you're going to count by if you're going to get to 23. It works out nicely to go ahead and count by 5s. That'll take you up to 25, so that'll work out nicely. And then your largest time value is 1 second. So decide what you're going to count by to get up to 1 second on the time axis. And it turns out nicely to count by 0.1. And then 0.2, get it right kind of small here. And all the way up until you get to 0.8, 0.9, and then 1 second. Okay? And I'll just remind you about how we plot those. So your time column is going to be what I call the over column. So you'll go over that number, and then you'll go up this number. Okay? We're actually done with this position data, so I'm just going to put kind of a light line over it, because I'm done with that now that I've got my velocity column. Okay? So I'll start with going over 0 and up 0. So it'll be right here at what we call the origin. Okay, the next one would be over 0.1 and up 1. Over 0.1 and up 1. That's going to be very close to 0. My next one is over 0.2 and up 4. So I'm going to go over to 0.2.